All right, so the password for the next level is stored somewhere on the server and has the following properties. It's owned by user Bandit7, owned by group Bandit6, and it's 33 bytes in size. So let's start with the bytes, and also let's explore the file structure to see what we got going on. All right. Okay, there's nothing in here. Okay. Let's do print working directory. It shows us that we're in home/bandit6. So if we go up one and list what's in here, whoa. Interesting. Right, because it's got all their other stuff on here. Okay. And then if we go up one more, this is the actual root directory, and it shows us everything. Okay. It's somewhere on the server. Let's do the same trick, starting in this directory, and let's look for a type f dash size, and they said 33 bytes. 33C. Why isn't it typing? 33C. There we go. Let's see what we... That's wonderful. Oh, man. Oh, look, we got some permission denied. That's great. Okay. Oh, let's see what we got going on here. So that was insane. So I cleared that out. Let's go back to the find command. Actually, let's go to the root. There we go. Okay, so we're in the root of the server. So we need to find, it needs to be owned by Bandit, the user, Bandit7, and the group Bandit6. Is that right? User Bandit7, group Bandit6. Okay, so with find, we're going to start here, dot. We're going to put type F for file. Size, we're doing 33C because it's 33 bytes. Dash user Bandit7 and group Bandit6. It narrowed it down somewhat. Okay, so that gave us just a ton of it gave us a ton of things that you see permission denied. So these are all errors. There is a shortcut for this in Linux that I can teach you real quick. It's you can pipe things into the null space, which is it's /dev/null in a Linux environment, which is just, it's kind of like this empty void /recycle bin, if you will, where it pipes out the, the processes so that you only get positives and not negatives. Because all these permission denieds, those are like negatives, right? And the negatives or errors are resulting with the number 2 in computer science and Linux. So basically all of these that you see that are permission denied, this doesn't do us any good except for one, which is this guy right here. var lib dpkg info bandit7.password. That is a result that we were looking for. But just real quick, let me show you what that looks like. So I cleared it out. If I ran the same one, I could take the errors, which are 2, and put that into /dev/null. I think is how that works. And yeah, that just gives us, it's much cleaner, and it gives us the very, clean, hey, this is your only positive. So file size 33 bytes. The user that owns it is Bandit7, and the group that owns it is Bandit6. So let's pop into var lib. Oh, you know what? We could just cat it, actually. Let's just cat it. And we're using the absolute path of var lib tpkg info bandit7 dot passwords. And there's our password to get into Bandit7. And I'm going to add that to our notes. So the important thing here, this took a lot of time, and it was a lot of manually going through directories, right? And manually searching for things. And this is also to show you that there are a lot of shortcuts. Now they can get really confusing. These one-liner commands like this up here, feeding all these arguments, it can get really confusing in a Linux environment. But the important thing to remember is that when you do this, you can look up, I mean, just Google search, like how do I use the find command to find a file? And how do I say that it's a file? How do I limit the size? How do I limit the user? And, how do I even pipe the errors so that I only get the positives of my output? And that's what's really important, is that there's manual stuff you do, and there's also things you can do to cut down the results and cut down the guesswork so that you can really fine tune it. I mean, what if you're doing digital forensics, not just ethical hacking, but digital forensics, and you end up finding having to find a file that is 33 bytes because it was the file that gave them a backdoor to introduce malware or ransomware onto the system. Device forensics and incident reporting, DCIR, I think is what it's called. That's really big these days, as well as ethical hacking in the realm of cybersecurity. So that's something I would also consider. So